I forgot to do one problem from the previous one, but that's okay. We can do it here. So given f of x equals 3x squared minus 1 and g of x equals 2x, find f plus g of 4. So what f plus g, whoops, what f plus g of 4 really means is that you're taking f of 4 and adding it to g of 4. So you're going to take f of 4, which is going to be basically this guy. You're going to plug in the 4 in there. So you're going to have 3 times 4 squared minus 1. That's the first guy. And then you're going to take g of 4, which is basically plugging in 4 in there. It's going to be 2 times 4. So this is going to give me 16. And then you're going to take 16 and multiply it by 3. That's going to give me 48. So this whole thing gives me 48. And I subtract the 1. You're going to get 47. Plus, and then this guy's going to give me an 8. Okay, so 47 plus 8 is just going to give me 55. Okay. So nothing too bad. And then in this case, if I didn't ask for the domain, but if you wanted to find the domain of f plus g of x, then you can look at the domain of f of x, which is going to be the 3x minus 1. This is a polynomial, so you know it's all real numbers. The other guy is g of x, which is 2x. You know this is also a polynomial, so this is all real numbers. And you can see that everything, they both have everything in common, so that means everything is going to be all real numbers as well. Okay, and if you want to practice, why don't you practice figuring out the domain of this, f of g of x? Why don't you try it out? And I think the domain is going to be something like this, from negative infinity to 0, 0 to infinity. So you can go ahead and check that if you want to. Okay, so we're going to move on to the next section now. This is function compositions. So you can take a moment to write this down if you'd like. So when the output of one function is used as the input of another, we call the entire operation a composition of functions. So for any input x and functions f and g, the following action defines a composite function. So basically, this is just another notation. So this kind of looks like fog, but it's f of g of x. So this is like a little circle right there, like a little small 0. So f of g of x, so the way that you say this is f of g of x, is basically plugging in a function inside of another function. Okay, that's basically what that means. Not to be confused with the multiplication of functions. So this guy is not the same as f of x times g of x. So those two are not equivalent. So you're basically plugging a function inside of another function. Okay, and I'll give you some examples of what that looks like. So one of the things that we might want to be interested in is how do we find the domain of this guy? So basically, the domain. So let's just write it down. The domain of the composite function f of g is all x such that x is in the domain of g and g is in the domain of f. Okay, so basically what this is saying is that you need to make sure that since you're plugging in g is now going to be part of the domain of f. So you need to be able to check the domain of g, and you got to make sure that you check the domain of f when you plug in the g. Okay, so in other words, what that basically means, especially if you're a little bit confused, you're basically going to have to find two different things. You're going to have to find the domain of g, and then you're going to have to find the domain of f of g of x, of the resulting one. Okay, this together is going to be the domain, okay? So those are the two things that you kind of have to figure out, okay? So let's start off by doing a couple of examples. So given that f of x equals the square root of x plus 2, and then g of x is 3 minus x. Let's say we want to find f of g of x and its domain. Okay. All right, so now what we want to do is let's first start off by finding out, by plugging in f of g of x. So basically, f of g of x, what I'm doing is that I'm taking this g of x, which is this 3x minus 3 minus x. Okay, so f of what am I plugging in? So g of x is just 3 minus x. That's what g of x is. And what I'm going to do is I'm going to plug that thing into the f. So let's locate where x is. So here's x. I'm going to put parentheses around it, plus 2. And what am I going to plug in there? I'm going to plug in the 3 minus x. Okay? So this is going to be equal to the square root. So this 3 and this 2 is going to give me a 5 minus x. So this guy is equal to f of g of x. Okay? All right, cool. Now, all we got to figure out is the domain. So remember, in order to find the domain of this guy, you got to figure out two different things. You got to find the domain of g first. Well, g in this case is just this 3 minus x. That's just all real numbers. Okay. Now we got to do the second thing. The second thing is finding the domain of the resulting function, the one that we just calculated. Okay. So we have this square root of 5 minus x. So remember, with square roots, we want to take the inside and setting it greater than or equal to 0. So we're going to subtract by 5. So we have negative x is greater than or equal to negative 5. We're going to divide by this negative 1, but remember, when we divide by a negative within an inequality, the sign changes to a less than. Okay, that's going to be a 5. And now what we're going to do is we're going to take both domains and we're going to combine them together. So the first one is all real numbers. That's really easy. We just put everything together. And then the other one is 5. It's included, and it's everything that's less than. So it's all of this guy. So now what we got to do is see what both of these guys have in common. So they have this thing in common all the way until 5. Everything else is not included. So it's going to be from negative infinity. Oh, I don't know if you can see that. So it's going to be from negative infinity all the way until 5, and I'm including that guy. So this is the domain of that guy. Okay. Okay, so now let's do another problem. So let's say I give you f of x equals 1 over x, and g of x equals 1 over x plus 3, x minus 1. And what I want to find is find g of f of x and find the domain. Okay, so now in this case, what we're doing is now we're plugging in the f into the g. So if I write g of f of x, well, f of x in this case is just equal to 1 over x. So we have g of f of x in this case, this f of x is just equal to this 1 over x. So that's what we're going to be plugging in. So let's write down g first. So if we look at g is 1 over x plus 3. We're going to leave that blank. x minus 1. We're going to leave that blank. And what are we going to plug into the x's? Well, into the x's, we're going to plug in this 1 over x. Okay, so that's basically what you're doing. You're plugging in one function into the other function. Okay, and this guy's going to be basically the answer. Don't simplify it. This is going to be really ugly to simplify, especially because we have to find the domain. Okay, now let's start off with finding the domain of this guy. All right, so the first thing that we got to look for, so remember to find the domain, is find the domain of G. Now in this case, we have to kind of be careful. Let me make this a little bit better. So when I say the domain of G, let's just say inside function. Whatever we plug into the inside, that's what we want to figure out, the inside function. And then this is the overall function. Okay, so maybe that way it won't be confusing. Okay, so the inside function in this case was f. This guy was the thing that we plugged in. So the inside, find the domain of inside, which in this case is a 1 over x. So what is the domain of 1 over x? Well, remember that the denominator cannot be equal to 0. So basically, for this guy, it's everything except 0. That is the domain of that guy, of the inside function. Okay, now we have to figure out the domain of overall function. So the overall function is 1 over x plus 3, 1 over x minus 1. Okay, so that's my overall function. Now notice here that what I have is another rational. And what I got to do is set that equal to 0. So I'm going to set the 1 over x plus 3 equal to 0, and the 1 over x minus 1 equal to 0. Okay, so that's just 1 over x plus 3 equal to 0, and then 1 over x minus 1 equal to 0. Okay, and now what we got to do is solve for this guy. So I'm going to subtract the 3 over. 1 over x equals negative 3. I can multiply the x to the other side. So I get the x's cancel out. 1 equals negative 3x. And then I just divide by the negative 3. So x equals negative 1/3. So this is one value that this cannot be negative 1/3. Now this guy, we're going to add the 1. You got 1 is equal to, 1 over x equals to 1. Going to move the x over, and you just get 1 equals x. So this cannot be equal to 1. Okay, so when I look at the domain is everything except 1 and negative 1/3. So it can be anything that I want except those two numbers. Okay, so now that I have both domains, I have to think about what do they both have in common. So the first break that they have is at negative 1/3. So you can see that I'm going to include all of this guy. Okay, I'm going to include all of this until I get to negative 1/3. I'm not going to include that because that's where they both have the first difference. Then everything seems to be good until you get to 0. So all of this space right here is good until I get to 0. 0 is not included. Then I continue on all the way until I get to 1. 1 also is not included. And then the rest of it is good as well. All of this is good. So my domain is going to be a lot. It's going to be from negative infinity all the way to negative 1/3, not included. Union negative 1/3 all the way to 0, not included. Another union 0 to 1, also not included. Union 1 to infinity, not included. So all of this mess is my domain. Okay. So a lot of things that are involved, but you have to, and notice that a lot of things are just building. So you need to be very comfortable with the domain, finding the domain of a function, okay? And it's all just practice. So the last one that we will just do is this problem, okay? So let's say I give you f of x is equal to 3 minus x, and g of x equals x squared minus 1. And let's say you want to find g of f of x, and then you want to find f of 2. Okay. So the first problem is relatively simple because all we are basically doing is just plugging in one function into the other. You have g of f of x. In this case, what is f? F is this 3 minus x. Okay, and what we're doing is that we're plugging this 3 minus x into g. So g, let's write down g. X, I'm going to put parentheses, squared minus 1. And I'm going to put in again the 3 minus x. So let's FOIL this out. So it's going to be 3 minus x times 3 minus x minus 1. FOIL this out, that's going to give me a 9 minus 3x plus x squared minus 1. So I like writing the x squareds first. This and this is going to give me a negative 6x. And then this guy and this guy is going to give me a positive 8. Okay, so that's that guy. So that's part A. Okay, and now let's do part B. So what exactly is f of 2? So let's rewrite this. So remember that this is just, we're writing f, and in the inside we're putting an f of 2. Okay. So the first thing that we got to think about is, well, we know what f is. That's just this 3 minus x. Okay. The first thing that I want to figure out is what exactly is this f of 2? So we have f of, so what are we doing with this other f? So this f of 2 is basically plugging in a 2 in there. So it's going to be 3 minus 2. Okay, because we're just plugging in the 2 into the f. So that's going to give me f of 1. Okay, and now what does this mean? We're going to go back to the f, which is this guy, 3 minus x, and we're now going to plug in 1. So it's going to be 3 minus 1, which in this case is going to give me 2. Okay. All right, so that's basically it for composite functions. Just make sure that you practice, and we can do more problems at some other time.